Hello Honors Pre-Calculus students, this is Mr. Casado, and the learning target here is to graph rational functions with slant asymptotes. So in the Desmos activity, you should have learned that a slant asymptote exists when the degree of the numerator is exactly one more than the denominator. And in order to find the slant asymptote, we divide. So if you look at problem number 1, in order to find the slant asymptote, we're going to divide. So you could use long division or synthetic. I'm going to use synthetic division in this particular problem. So I'm going to set it up as the following. And then in the synthetic division, we're going to drop the 1, multiply, add, multiply, and we get the following. So this means y is equal to 1x minus 5 plus 8 over x plus 1. And remember, asymptotes are the end behavior of the graph. So the limit as x goes to infinity of 8 over x plus 1 is equal to 0. So basically we could ignore the remainder because it goes to 0. So the slant asymptote is y equals x minus 5. If you look at this problem, we also know that x equals negative 1 is a vertical asymptote. You should also realize from our class discussion that a graph cannot have a horizontal asymptote and a slant asymptote. And then the other thing we're going to do is find the x and y intercepts. So if I find f of 0, we will get 3. And to find the x-intercepts, we're going to factor f of x. So if I were to factor f of x, if it's not factorable, you could use the quadratic formula, but this factors into x minus 3 times x minus 1 divided by x plus 1. So the x-intercepts are 3, 0, and 1, 0. At this point, we could take the information and sketch the graph. So the slant asymptote is x minus 5 is equal to y. So I'm just going to sketch the slant asymptote using the y-intercept and slope. Should hit that point at 5. So here's y equal x minus 5. The x-intercepts are 3 and 1. Those are the blue dots. The y-intercept is at 3. And we have a vertical asymptote at x equals negative 1. So I'm going to draw that vertical asymptote, move the graph up a little bit at x equals negative 1. Okay, so the graph has to hit the y-intercept and those two x-intercepts, and in the end behavior of the graph, it approaches the horizontal asymptote. So the graph is going to start at the top here, come down, go through that y-intercept and x-intercepts, and approach that. Now it is possible that this graph comes further down. So in calculus you'll be able to find the mins and the maxes. So it's possible, and we're not going to be grading this, Mrs. Gilbert and I, that it comes further down and maybe does something like that. With a graphing calculator, you should be able to tell that. It's possible that it just kind of is very low. It's really not easy to tell without calculus. The multiplicity in the denominator is 1. So on the right-hand side, we're at the top, so it has to start at the bottom. So the graph is trapped between these two asymptotes at the bottom. If you have questions, please make sure you ask your teacher. Okay, problem number 2 here is the same idea. In order to find the slant asymptote, we're going to divide. So I will divide synthetically again. Here we have a leading coefficient. So we're going to drop the 4, multiply, add, multiply. And this is the remainder here of 6. So we can ignore the remainder. So the slant asymptote is 4x minus 1. The vertical asymptote is x equals negative 1. I'm going to factor this function. If you're not good at factoring, you always could use the quadratic formula. So this factors into 4x plus 7 times x minus 1. So the intercepts, so the x-intercepts, are going to be negative 7 quarters, 0, and 1, 0. The y-intercept, so if we find f of 0, we're going to get negative 7. So at this point we got the intercepts, vertical and horizontal asymptotes. So now we can sketch the skeleton. So the horizontal asymptote was, the vertical asymptote is x equals negative 1. The slant asymptote is 4x minus 1, so here's negative 1, and then we're going to go up 4, 1, 2, 3, 4 over 1. So I'm going to sketch that slant asymptote. The x-intercepts were negative 7 quarters, so that's negative 1, negative 2, negative 3. So that negative 7 quarters might be approximately, that's negative 1 3/4, if I did my math correctly. So maybe right there. The other x-intercept is 1, 0. So that's going to be right here. The multiplicity on those x-intercepts is 1, so that goes through those two x-intercepts. And the y-intercept is negative 7. Negative 1, 2, 3, 4, 5, 6, 7. So here's negative 7. And we have a dot there. So the graph has to approach the asymptotes in the long run. So then the graph is going to maybe start down here on the left of negative 1, through the y-intercept, through the x-intercept, and approach that asymptote. And then on the other side, it has to hit the x-intercept of negative 7 quarters. The multiplicity around the x plus 1 is odd, so if we're starting at the bottom on the right-hand side, we have to be at the top. Over here where I put this kind of little arrow there. So it's going to start at the top there and kind of come down. Technically, it starts at the bottom and goes up since it is increasing on that side. Hopefully you found this example helpful, and we'll do 2 more. If you look at this problem, we can see that the degree of the numerator is 3, the degree of the denominator is 2, so there definitely is a slant asymptote. I'm going to do long division as an example here. You don't necessarily have to do long division, but I wanted to show you an example of a long division problem. So for long division, I'm going to write this out. So you ask yourself, how many times does x squared go into x cubed? And that's x times, I like to put it over the x, and then you multiply. X cubed plus 5x squared plus 4x. After that, you are going to subtract. When you subtract, you get, and let's put parentheses around here, you get negative 8x squared plus 0x, and we're going to drop the 12. Then you ask yourself, how many times does x squared go into negative 8x squared? And that's negative 8. So I'm going to multiply again. Negative 8x squared minus 40x minus 32. Again, I'm going to subtract. When you subtract, you get 0x squared plus 40x, and then that becomes plus 32, so it's plus 20. This that I'm highlighting in blue is the remainder, meaning it's 40x plus 20 over x squared plus 5x plus 4. That's the remainder. That remainder is going to go to 0 as x goes to infinity. So the slant asymptote for this particular problem is y equal x minus 8. There are other ways you could have found the slant asymptote in this particular problem. I'm going to factor the numerator and the denominator. So the numerator is factored by grouping, and the denominator is a quadratic. So the denominator is x plus 4 times x plus 1. If you factor by grouping, the numerator will become x squared plus 4 times x minus 3. I'm going to leave that as an exercise for you to verify. So looking at the function in factored form, the x squared plus 4 has imaginary zeros, but we do get 1 0 at x equals 3, so that's one x-intercept. In fact, it's the only x-intercept. We have vertical asymptotes at x equals negative 4 and x equals negative 1. Again, there cannot be a horizontal asymptote if there is a slant. The y-intercept, so if you find f of 0, you're going to get negative 3. So now we can come down to the graph and sketch the graph. The slant asymptote is y equal x minus 8, so 1, 2, 3, 4, 5, 6, 7, 8. Here's negative 8. Slope is 1, 2, 3, 4, 5, 6, 7, 8. So I'm just going to use those 2 points to sketch the slant asymptote. Y equal x minus 8. We said there is a vertical asymptote at x equal 1. I'm going to move this up a little bit. And another vertical asymptote at x equals negative 4. So the vertical asymptotes, I'm going to draw in. X equals negative 4. And x equals negative 1. I'm going to make my graph a little bit bigger. The x-intercepts we said was just 3. And the multiplicity on that is 1, so we know it goes through. And we said the y-intercept was negative 3. So the graph has to go through those 2 points, and it has to approach the slant asymptote in the long run. If you weren't sure how to draw this graph, you could find the limit as x approaches negative 1 from the right-hand side. So I'm going to write this down here. So f of x, just so you can see it, is x squared plus 4 times x minus 3 divided by x plus 4 and x plus 1. So if you were to plug in a number a little bit smaller, or excuse me, a little bit bigger than negative 1, like negative 0.9999, this term is positive, this term is negative, this term is positive, and this term is positive and small. So the limit as you approach negative 1 from the right-hand side will be negative infinity. That tells me it starts down here where I put the yellow highlighter. So the graph starts down here. It has to go up. It's okay to cross the slant asymptote. Hits the y-intercept, has to cross through that x-intercept, and in the long run it's going to approach that slant asymptote. The multiplicity on the x plus 1 in the denominator is 1. So I know the graph has to start at the top. It has to come down. There are no x-intercepts in there, so it has to turn around and approach -4 on the right-hand side towards infinity. The multiplicity on the x plus 4 is also 1. So the graph has to start down at the bottom here, turns up, and then it has to approach that slant asymptote. So there's a sketch of problem number 3, and then we're going to do one more example. Let's take a look at problem number 4. In problem number 4, we can factor the numerator. So x minus 3 times x minus 2 divided by 2x plus 7. From here, you should be able to see that the x-intercepts are 3, 0, 2, 0. The y-intercept, I like to plug 0 into the original, is 0, 6 over 7. There is a vertical asymptote at x equals -7/2. And since the degree of the numerator is exactly 1 more than the denominator, you can divide. I'm going to do long division. So x squared minus 5x plus 6. How many times does 2x go into x squared? 1/2 x. I'm going to multiply. So x squared plus 7 over 2x. Now I want to subtract. So then you get -5 minus 7/2. When you do that, and if you need your calculator to help you with the fractions, feel free to use your calculator. You get -8.5 or -17 over 2x. Then you would drop the 6. How many times does 2x go into -17 over 2? So you need to ask yourself 2 times what number is -17/2. So the question mark is going to be -17 over 4. So it's -17 over 4. When you multiply, you get -17 over 2x minus 17 times 7 over 4. I could use my calculator and multiply that out. When you subtract, what's left is the remainder. So at this point, I'm going to stop because I know the slant asymptote is 1/2 x minus 17 over 4. And 17 over 4 is around 4.25, and we're going to use that when we kind of graph. So we got the vertical asymptote, we have the slant asymptote, we have the intercepts. So let's take a look at the graph. So the 1, 2, 3, 4, so 17 over 4 is around 4.25. So I'm going to put a little dot here around -4.25. So just for clarity, this is -4.25. Then I'm going to go up 1 and over 2. So I'm going to use these 2 points to draw my slant asymptote. So this is y equal 1/2 x minus 17 over 4. We said that there was a vertical asymptote at -7 over 2. X equals -7 over 2. So -7 divided by 2 is -3.5. 2, 3, 4. So here's the vertical asymptote. X equals -7 over 2. The x-intercept we said was 2 and 3. So the x-intercepts are 2 and 3. The y-intercept was 6/7, so it's pretty close to 1. I'll just put that dot there. So the graph goes through the two x-intercepts and has to approach the asymptotes. So based on what we've done before, since I have to approach the asymptotes, and if you're not sure, you could do the limit as x approaches -7/2 from the right of the function. And I forgot what I called the function, f of x. So if you wanted to, you could do the limit as you approach -7/2 from the right. I'm going to write that down here. So if you approach a number a little bigger than -7/2, this number is negative, this number is negative, this number is going to be a small positive, so this is going to go to infinity. Some of you may not have needed to do that, but the graph starts at the top here where I put the yellow highlighter, comes down, hits the y-intercept, goes through those two x-intercepts, and approaches the asymptote. Since the multiplicity on the 2x plus 7 is odd, we know it has to start down at the bottom where this green highlighter is. So the graph starts down at the bottom, goes up, and has to turn around and approach the slant asymptote in the long run. So hopefully this was a good review of slant asymptotes.